So today we're going to be talking about concave and convex mirrors. Okay, so the formula used to measure the image of the distance of the image, distance of the object or the focal length, is 1 over f, which is your focal length, equals 1 over di, which is the distance of the image, plus 1 over do, which is the distance of the object. Okay, so that's your basic formula for mirrors. So we're going to use that formula. We're going to apply it to a problem. So we're going to write it up in this corner over here. 1 over f equals 1 over di plus 1 over d. So this question right here says, for a concave spherical mirror has a focal length of 10 centimeters. So you're going to have the f equals 10 centimeters. And it says, locate the image and find the magnification of an object at a distance of 25.0 centimeters in front of the mirror. So the distance of the object equals 25.0 centimeters. And we want to find the magnification of its image and the distance of its image. So we're going to draw a ray diagram, and it's going to go like this. You have your straight line, straight line, and then you're going to measure, actually, where you want your mirror to be, which is going to be, let's say, we're going to put it over here. And then you have that, which is, so we can do 4. So right here is the focal length, and that's 10 centimeters. And the distance of the object is, the object's over here. So we have roughly 25 centimeters over here, and that's your f. So first off, we're going to draw our parallel ray, and that is basically the ray that goes parallel to the mirror from the object. Actually, I forgot to draw the object. Whoops. Your object is going to be right here. It's going to stand up kind of straight like that. So we're going to draw it parallel. So it's going to go parallel to the object, and then right when it hits the mirror, it's going to go through the focal length. And that's going to be our parallel ray. So let's label that parallel. And then there's 2 different rays you can use next. There's the focal ray, the focal ray. Yes, the focal ray and the central ray. So depending on which one, the central ray, you have to have the center of curvature, and we don't really mark the center of curvature. So we're going to use the focal ray. And the focal ray is basically the ray which goes through the focal length. So it's going to go like this, straight through the focal length, and it's going to come out parallel, like that. So it's opposite of a parallel ray, because it goes, instead of going parallel and then through the focal point, it goes through the focal point and then parallel. So this is our focal ray. Alright, so the way we know where our image is by where the rays intersect. So they intersect right here, and as you can see, it's upside down, which means that the magnification of the image is going to be negative. So we can now calculate the distance of the image by using our formula up here, which is 1 over f, which is 1 over f in this case is 10 centimeters. So it's 1 over 10 centimeters equals 1 over dO, which is the distance of the object, which is 25.0 centimeters, plus 1 over di, which is the distance of the image, but we don't know that yet. So if you do the math, you bring this over here, so we have 1 over 10 minus 1 over 25 equals 1 over di, and that gives us 1 over di, which actually we can just do di, which is going to be the inverse. So it's di equals 16.6 centimeters. And that actually looks about right because it's between 25 centimeters and 10 centimeters. And it's not going to be that accurate because I didn't actually use the actual centimeters on a ruler, so it's not going to be accurate, but you can tell that it's right, it's pretty much there. So now we want to find the magnification, and the magnification, the formula for magnification is magnification equals negative distance of the image over distance of the object. So that means we have m equals negative 16.6 over 25. And that is going to come out as negative 0.644. So our magnification is negative, which is right because it's upside down. So the magnification is negative, and it's negative 0.644. So that's our magnification. This is the distance of the image, and we drew our ray diagram, and that's all you need to know.